Hi, welcome to Sparse matrix session. The matrix can be defined as two-dimensional array that will have m number of rows and n number of columns. A matrix with m rows and n columns can be called as m by n matrix. The simple matrix is used to store the elements in horizontal or vertical position. The elements can be accessed by using the uh, row number and column number. The sparse matrix can be defined as the matrix which is having majority of its elements equal to 0. For example, here it is given the sparse matrix, the majority of the elements in the given matrix is 0 elements. Only few elements are non-zero elements, like here 3, 4, 2, uh, 2, 3, 1. Only few elements are non-zero elements. The number of zero elements are greater than the non-zero elements. So here the non-zero elements are very less in the sparse matrix, so that's why it is called as a sparse matrix. So here the sparse matrix is used to reduce the storage space because which is having very less number of non-zero elements, so only it will consider the non-zero elements for calculation, so it needs very less memory or when comparing with other concepts. So since it is using only the non-zero elements to access from the matrix rather than accessing all the elements, it is reducing the computational power logically. So here when we have this zero elements are here more than non-zero elements. Non-zero elements are here only 5 in the among 20 number of elements. So 15 elements are zero elements and 5 numbers of non-zero elements. So it will access only the 5 elements during the calculation. So it will reduce the computational power. Representation of the sparse matrix can be done using triplets that which is having row number, column number, and values. It can be represented by using two data structures, array and linked list. First, we will see the sparse matrix using array representation. The sparse matrix can be represented by a two-dimensional array, which is lead to wastage of memory. Here, the sparse matrix stores many zeros than non-zeros which are not using for calculation. So to avoid the wastage of memory location, we are going to use only the non-zero elements. It reduces the traversal time to access the element in the sparse matrix and also reducing the storage space. The array representation for sparse matrix is having three fields. One is row number, column number, and value. Row is indicating the row number which is available non-zero element, and column is column number which is having non-zero element. Value is the which is the non-zero element which is located in row and column. For example, the given graph is having five number of nodes or vertices. So this five number of vertices are having number of edges, so that is represented by using the sparse matrix. For example, from vertex 1 to 2 we are having the weight value is 3. So from row number is one source and destination is column number 1 to 2 we are having the weightage 3, so it is represented in the sparse matrix. For example, 3 to 4, so 3 to 4 we are having the weightage 3, so 3 to 4 we are having the weight 3, so it is represented in the sparse matrix. So here we are having 20 memory 20 locations in the 5 by 4 matrix. So in this we are having 15 zero elements and 5 non-zero elements. So here 6 non-zero elements, 14 0 elements. Okay, so here when we are accessing this memory locations, when memory locations, when you are increasing the number of vertices and the number of edges, there's the possibility of increasing number of wastage space. For example, if you increase one more vertex here, suppose 6, so 6 to 5, if we have one edge 2, then we have to add one more row here in the sparse matrix with 4 values like 6 to 1 0, 6, so 6 to 5 0, 6 to 3 0, 6 to 4 0, 6 to 5, one more column will come, so 6 to 5 will be 1. So look at that, we will add more number of zeros here, and we are adding only one value, so it is increasing. So 6 by 5 matrix, it will need 30 memory locations, and but it is having non-zero elements are only 7. So it is a wastage of memory when you are increasing the size of the matrix. So the table representation can be given for the array representation of the sparse matrix. So the value 3 can be represented with row number and column number. So row number is 1, column number is 2, the value is given 3. And if you take the this value, so row number is 5, column number is 2, right, then value is 1. So here we can use the table structure to represent the sparse matrix by using the array. So here we are in need of 3 arrays. So row is one array, column is the second array, value is third array. So here we are in need of, for this 6 values, we are in need of only 18 memory locations, but sparse matrix here it is taking 20 memory locations. When we are implementing the sparse matrix by using array, we are saving the memory locations by 2 in the out of 20 memory locations. So here it is taking only 18 memory locations as per the discussion in the previous slide, but the sparse matrix is taking 20 memory locations. Then why do we need sparse matrix? Here we are having only 5 by 4 matrix, so here 20 memory locations, but we are storing only the 6 values. Okay, but when you are taking the large data, for example, we are taking 10,000 rows and 50 columns in the sparse matrix, it is in need of 5 lakh 5 lakh storage space in the sparse matrix. But assume we are having only 10,000 non-zero elements. If you are having 10,000 non-zero elements, during the computation we will take only 10,000 elements for accessing the values, for accessing the non-zero values. So it will take less memory locations when comparing with other kind of matrices. So this sparse matrix, when you are implementing in the array representation, then it will take three arrays for each value. One is the row array, and another one array is for column, another one array is for value. For 10,000 values, you need only 30,000 memory locations to represent the sparse matrix using array. So it will take less number of memory locations than 5 lakh memory locations. So the sparse matrix is used to reduce the computational power. The time complexity will be number of rows and m number of columns in the matrix. So it will access the elements wherever it is available in the matrix. So order of nm. Space complexity, to store the values we are in need of order of nm. Thanks for watching.